Good morning, everyone. I am Sheeba, Assistant Professor in Emmanuel Research, JJ College of Engineering. Today, I am going to discuss about components and types of combustion chamber. A combustion chamber is a part of an engine where fuel burns. It converts chemical energy into heat energy. It used in engines, gas, turbines, and rockets. A combustion chamber is a part of an engine where fuel burns in the presence of oxygen. The burning process is called combustion, in which the chemical energy of the fuel is converted into heat energy. This heat produces high pressure gases that expand and do useful work, such as moving pistons in engines, rotating turbines in gas turbines, or producing thrust in rockets. Therefore, the combustion chamber plays a vital role in energy conversion and power generation. Purpose of combustion chamber. The combustion chamber is designed to ensure that fuel burns effectively used and safety to produce maximum useful energy. First point, efficient burning of fuel. It's nothing but the chamber allows proper mixing of fuel and air. This ensures complete combustion. It reduces fuel wastage. It ensures complete and efficient burning of fuel by proper mixing of air and fuel. Second point, maximum energy output. It means efficient combustion releases more heat to more expansion of gases, go to more work. It follows energy conversion. It helps in obtaining maximum energy from the fuel for better engine performance. Third point, minimum pollution. It helps in cleaner operations. It reduces pollution by ensuring complete combustion and fewer harmful emissions. Fourth point, safe and controlled combustions. Designed to handle high temperature and pressure. It prevents explosion of damage. It ensures smooth burning. It provides safe and controlled combustion to protect the engine and ensure stable operations. The purpose of a combustion chamber is to ensure efficient burning of fuel by proper mixing of air and fuel. It helps to produce maximum energy output by converting chemical energy into heat energy. It also minimizes pollution by promoting complete combustion and ensures safe and controlled burning under high temperature and pressure conditions. Main components of combustion chamber. First one is casing, second one is fuel injector, third one is igniter, fourth one is air inlet, fifth one is flame tube, and sixth one is exhaust outlet. First one is casing. The casing is the strong outer covering by an engine or combustion chamber that surrounds and protects all internal parts. First point, strong outer covering. It acts as like a ridged frame around the system. It holds all components in proper positions. It provides structural strength. Second point, protects internal parts. Shield the inside parts like fuel injector, valves, combustion areas. It prevents damage from dust, vibration, and external impact. Inside the third point withstands high temperature and pressure. The inside the combustion chamber gases reach very high temperature and pressure due to combustion. The casing is designed using strong metals so it does not melt or break. To ensure safe and stable operation of the engine, the casing or outer shell is the strong outer covering of a combustion chamber or engine. It protects the internal components from damage and keeps them properly enclosed. It is specially designed to withstand very high temperature and pressure produced during combustion, ensuring safe and efficient operation of the engine. Next one is fuel injector. A fuel injector is a device in an engine that supplies fuel into the combustion chamber in a controlled and a fire spray form. First point, sprays fuel into the chamber. It breaks fuel into a fine mist or spray. This helps to fuel spread evenly inside the chamber, improves burning efficiency. Second point, ensures proper mixing with the air. The fine fuel spray mixes easily with the incoming air. This leads to complete combustion. Better mixing is equal to better engine performance. For that point, controls fuel flows. The injector regulates how much fuel enters the chamber. It ensures the correct fuel air ratio, prevents excess fuel or fuel wastage. A fuel injector is a device that sprays fuel into the combustion chamber in a fine mist. It ensures proper mixing of fuel with the air for efficient combustion and controls the amount of fuel supplied to maintain the correct fuel air ratio. This improves engines efficiency and reduces fuel wastage and pollutions. Next point, ignitors. An igniter is a device used in engines to start the combustion process by producing a spark or heat. First point starts the combustion process. The igniter initiates the burning of fuel air mixture. It provides the first energy needed for combustion. Without it, fuel will not start burning. Second point, produces spark or heat. In petrol engine, it produces a spark or spark plug. In some system, it produces heat to ignite fuel. This triggers combustion. Third point, used during engine startup. Works only at the beginning of engine operations. Once combustion start, it is no longer needed continuously. Helps the engine start smoothly. An igniter is a device used in engines to start the combustion process. It produces a spark or heat that ignites the fuel air mixture. It is mainly used during engine startup to initiate combustion and ensure smooth engine operation. Next, air inlet. An air inlet is the part of the engine that allows air or oxygen to enter the combustion chamber for burning fuel. First point, supplies air or oxygen for combustion. It brings fresh air into the engine. Air contains oxygen needed for combustion. Without oxygen, fuel cannot burn. Second point, helps maintain correct air-fuel ratio. Ensure the right balance of air and fuel. Proper ratio is needed for complete burning. Too much or too little air reduced efficiency. Third point, ensure efficiency burning. The proper airflow improves fuel mixing, leads to complete combustion, produces more energy and less pollutions. An air inlet is a part of an engine that supplies air or oxygen needed for combustion. It helps maintain the correct air-fuel ratio and ensure efficient burning of fuel. This improves engine performance and reduce waste and pollution. Next one is flame tube or combustion liner. A flame tube or combustion liner is the inner part of a combustion chamber where the actual burning of fuel takes place and the flame is controlled. First point, inner part where burning occur. It is the main region where fuel and air burn. Combustion happens inside this tube, produces high temperature gases due to combustion. Second point, guides and stabilize the flame. Keeps the flame steady and controlled. It prevents the flame from blowing out. It ensures smooth and continuous burning. Third point, protects outer casing from heat. Acts as the heat shield for the outer structure. It reduces direct heat damage to the casing. It improves safety and durability of the engine. A flame tube is the inner part of a combustion chamber where fuel actually burns. It helps guide and stabilize the flame so that combustion remains steady and efficient. It also protects the outer casing from high temperature and ensure safe operation of the engine. Next point, exhaust outlets. An exhaust outlet is the part of an engine or combustion chamber through which burnt gases leave after combustion. First point, release burnt gases. It allows hot gases produced after combustion to exist. It removes waste gases from the chamber. It keeps the system ready for fresh air fuel mixture. Second point, directs gases to turbine or exhaust system. Guides high pressure gases in the required direction. In gas turbine, gases flow to spin turbine blades. In engines, gases go to the exhaust system. That point helps maintain pressure flow. Maintain continuous flow of gases. It prevents pressures build up inside the chamber. Ensure smooth engine operation. An exhaust outlet is a part of the engine that release burned gases after combustion. It directs these gases to the turbine or exhaust system and helps maintain proper pressure flow inside the engine. This ensures smooth and continuous operations. Additional components. These are supporting parts that improve the performance. safety and efficiency of the combustion process. Cooling system provide passages for air to flow around the chamber, removes excess heat generated during combustion. It prevents overheating and damage to engine parts. It improves durability and safety. Second point, swivel vents or improve mixing. Create a swirling motion of incoming air. It improves mixing of fuel and air. It helps to achieve more complete combustion. To increase efficiency and to reduce emission. Next point, sensor or temperature pressure. To measure temperature and pressure inside the chamber. It helps monitor engine performance in real time. It allows control system to adjust fuel and air supply, prevent unsafe operating condition. Additional components of a combustion chamber include cooling system, swivel vents and sensor. Cooling system remove excess heat and prevent overheating. Swivel vents improve mixing of air and fuel for efficient combustion, and sensors monitor temperature and pressure to ensure safe and controlled engine operation. Types of combustion chamber. There are three main types. First one is can type, second one is annular type, third one is can annular type. Let's see first type, can type combustion chamber. A can type is a design used in gas turbine engine where combustion takes place in separate cylindrical units called cans. First point, consists of separate cylindrical chamber or can. The combustion system is divided into multiple individual chambers. Each chamber is a self-contained unit. These are arranged in a circular pattern inside the engine. Second, each can has its own burner. Every can contains its own fuel injector and a flame system. Combustion happens independently in each can. This improves reliability and easier maintenance. Airflow is divided among cans. The compressed air from the compressor is split into all cans. Each can receives a portion of air for combustion. It ensures balanced burning across the engine. A can-type combustion chamber consists of separate cylindrical chambers called cans. Each can has its own burner where combustion takes place independently. The compressed air is divided among these cans to support efficient and controlled combustion, making the system reliable and easy to maintain. Advantages of can type. A can type combustion chamber has separate cylindrical chamber or cans, and this design provides several benefits. First one is easy to design and test. Each can is separate unit. Engineers can design and test one chamber at a time. Faults are easier to locate and fix. Maintenance and replacement become simpler. Second point, good combustion control. Each can has its own burner and fuel supply. Combustion condition can be controlled individually, leads to stable and efficient burning, improves overall engine performance due to better combustion. The can-type combustion chamber has several advantages. It is easy to design, test, and maintain because each can works as an independent unit. It also provides good combustion control since here each chamber has its own burner, allowing stable and efficient combustion. Next, disadvantages of can chamber. Although the can-type combustion chamber is easy to design, it also has some drawbacks. First one is bulky and heavy. The use of multiple separate cans increase size and weight. Takes up more space inside the engine. It's not suitable for compact or lightweight design. Second point, less efficient airflow. Air is divided into separate chamber. This can reduce smooth airflow through the system. It may cause pressure losses and lower efficiency. Third point, non-uniform temperature. Each can operate separately. Temperature may vary from one can to another. This can lead to uneven heating and performance imbalance during combustion. The disadvantages of a can-type combustion chamber are that it is bulky and heavy due to multiple separate chambers. It has less efficient airflow because air is divided among cans, which can reduce performance. It may also cause non-uniform temperature distribution, leading to uneven combustion and a reduced efficiency. Next, annular type combustion chamber. An annular combustion chamber is a modern design where the combustion space is a single continuous ring-shaped chamber around the engine. First point, single continuous ring-shaped chamber. The chamber is shaped like a ring. There are no separate cans. This chamber fuel is injected evenly around the ring. Combustion happens in one continuous space. Second point, air flows smoothly through one space. Compressed air moves in the smooth circular path. No division of airflow into separate chamber. This improves efficiency and reduces pressure losses. It ensures uniform combustion. Third point, common in modern engine. It used in advanced gas turbine and jet engine. It preferred in aircraft engines due to efficiency and compact design. It provides better performance and lower weight. An annular combustion chamber is a single continuous ring-shaped chamber used in modern engines. Air flows smoothly through one space without being divided, which improves efficiency. It is commonly used in modern gas turbine and jet engines due to its compact design and better performance. Next, advantages of annual type combustion chamber. The annual combustion chamber has several important benefits due to its continuous ring shaped design. First point, lightweight and compact. It has a single ring shaped chamber instead of multiple cans. It requires less material and space. It makes the engine smaller and lighter. It is suitable for modern high-speed engines. better efficiency. Air flows smoothly without interruption. Less pressure loss compared to can type chamber. It improves fuel burning and overall engine performance. It leads to more efficient combustion. Third point, uniform temperature distribution. Heat is spread evenly throughout the chamber. It reduces hot spot and thermal stress. It improves engine life and stability. The advantages of an annular combustion chamber are that it is lightweight and compact due to its single ring shaped design. It provides better efficiency because of smooth airflow and reduced pressure loss. It also ensures uniform temperature distribution, leading to stable and reliable engine operation. Disadvantages of annual type combustion chamber. Although the annual combustion chamber is efficient, it also has some drawbacks. First one is difficult to design and maintain. It has a single large ring shaped structure. It requires precious engineering and manufacturing. To repairing or accessing internal parts is difficult. To maintenance is more complicated compared to can type. Second point, complex cooling. High temperatures are spread over a large continuous area. It needs an advanced and carefully designed cooling system. Uneven cooling can damage the chamber or reduce efficiency. Third point, cooling complexity. Cooling must be uniform across the entire ring. Small imbalance can cause overheating in some regions. This makes the system technically challenging. The disadvantages of an annular combustion chamber are that it is difficult to design and maintain due to its complex ring structure. It also requires a complex cooling system to manage high temperature evenly, making it more technically challenging compared to other types. Next one is can annular type combustion chamber. A can annular combustion chamber is a hybrid design that combines features of both can type and a annular type combustion chamber. First point, combination of can and annular type. It uses multiple individual cans arranged inside a common annular outer casing. It combines the strength of can type and the efficiency of annular type designs. Each can has its own combustion zone, but they share a common airflow system. Second point, multiple can inside a common outer casing. In several cylindrical cans are placed around the engine core. All cans are enclosed within one outer shell. Air is distributed to each can for combustion. This improves balance and performance. Third point, used in many aircraft engines. Commonly used in modern gas turbine engines, especially in aircraft where reliability and efficiency are important, provides a good balance between performance and maintenance. A can annular combustion chamber is a combustion of can type and annular type design. It consists of multiple can placed inside a common outer casing. Air is supplied to each can for combustion. This type is widely used in aircraft engines because it offers a balance of good performance, reliability, and efficiency. Conclusion. Three main types: can annular. Second point, each has unique benefits and drawbacks. Third point, choice depends on application and design needs. There are three main types of combustion chamber: can type, annular type, and can annular type. Each design has its own advantages and disadvantages based on structure, efficiency, weight, and maintenance requirements. The can type is simply and easy to design but bulky and less efficient in airflow. The annular type is lightweight and highly efficient but difficult to design and maintain. The can annular type combines features of both, offering a balance between performance and reliability, and is widely used in aircraft engines. Therefore, the selection of combustion chamber type depends on the application, engine requirements, and design priorities such as efficiency, cost, weight, and easy of maintenance. Hope you all understand. Thank you.